So let's go ahead and practice doing some hypothesis tests for means. The report highest paying jobs for the 2009-2010 bachelor degree graduates states that the mean yearly salary for offer for students graduating with accounting degrees is $4,872. Suppose that a random sample of 50 accounting graduates at a large university who received job offers resulted in a mean offer of $49,850 and a standard deviation of 3,300. Do the sample data provide strong enough support for the claim that the mean salary offer for accounting graduates is higher than the national average? So we have the national average is up here, right? And we want higher than. So, and again, the way you can find strong support, so that's like convincing evidence for the claim of what? That it's higher than the national average, okay? Now our sample, let's go ahead and highlight that in a different color. Our sample got 49,850 and a standard deviation of that. So we will need that. Okay, so what are the hypotheses? Well, you're going to find that the first one always takes this form with an equal sign right here. So that one's an equal sign. This one has to look like what they're looking for support for. So they're saying, oh, what is there support that it's actually higher? So that's why it has the greater than. And you can see the number we used is the same number right there. So that number comes down into here. Okay. What is the level of significance? So use alpha equals 0.05. Alpha is the level of significance. So make yourself a little note. I'll add a note here. All right. So, and here, by the way, you can see it's exactly the same number. It's 0.05. And actually, let's go ahead and take a look at this one. Oh, we'll just get down to this here. What is the statistic from the sample? So that would be this right here. So it didn't say test statistic, it just said statistic. And that means your sample average. And what sampling distribution will you use? Oh, I just noticed it's a little short here. The sampling distribution we will use is the t-distribution. Okay, so let's go look at the other side. A credit bureau analysis of undergraduate students' credit records found that the average number of credit cards in an undergraduate's wallet was 4.09. It also reported, so that sounds kind of like a number that's going to come back up. And so 4.09, right? It is also reported that in a random sample of 132 graduates, so there's our sample. Oh, by the way, I'll count the 50 there. There's 132 graduates. The sample mean number of credit cards that the students said they carried was 2.6. Assume a sample standard deviation of 1.2. Is there convincing evidence? So that's the part we want. Is there convincing evidence the mean number of credit cards is less than 4.09? So that 4.09 is the number that goes into the hypothesis, right? And since we said less than, oops, I went ahead and double highlighted instead of underlined. Less than, that leads you to your alternate hypothesis. And then, of course, your null hypothesis is that it is just equal. The level of significance is still 0.05, all right? And what is the statistic? Well, that's from your sample right here. Okay, from sample. Maybe we should write a little note. Statistic is from the sample. All right. And what sampling distribution will we use? We're going to use a t-distribution. That's what we'll use. Why are we using a t-distribution? Well, the kind of tests we're doing are called t-tests. And it's a lot like a normal distribution, but it just because we're using estimated standard deviations, that 1.2 there and that 3,300, That's why we're using a t-distribution. Okay. So what is the value of the sample test statistic? The easiest way to do this is to go ahead, and let me move this off so I can see my numbers here. And to go to stapplet. And what kind of variables are we dealing with? It's a quantitative variable, and it's just one. And one case is salary, right? And we can, before we do this, we don't have raw data, so we're not going to do that. We are going to put in mean and standard deviation. Let's make sure you can see that just fine. All right, mean and standard deviation. And this is from the sample, so make sure you put in the numbers from the sample. The sample had 49,850. Standard deviation was 3,300. Sample size was 50. And begin analysis. And you got a couple options here. We are never doing these for quantitative data. All right, so you can ignore those two. We're doing something similar to these for a different set of data at the very end of school. All right. We're not trying to estimate. We're trying to find evidence. So you see convincing support for the claim. So they're not saying estimate it. They're asking you, So that's called a test. All right. And then here, this is very important because these are not all the same. And see how it says alternate hypothesis, right? Alternative hypothesis. So that means you have to come back and look at this. What does this say? Greater than 48,722. And perform your inference. And boom. And you have 2.417, 0.0097. And if you look here, there it is. So the sample test statistic is the one with the T on it. Oh, let me make this. And the p-value is the one that says p-value. All right, let's go ahead and do it for this one over here. So we'll do the stapplet again, edit my inputs. This time we're looking at credit cards. And the sample mean was 2.6, standard deviation was 1.2, and it was the sample size of 132. And again, we're doing a t-test. And let's look at our alternative hypothesis. Here it says less than 4.09, so let's make it match. And perform the inference, and there it is. All right. So our test statistic is negative 14.2657, and our p-value is 0.0. It's actually smaller than 0.001. So, do we reject or fail to reject? Well, both of these p-values are very tiny, so we're going to reject on both of them because the p-value is less than our alpha of 0.05. All right. And then how do we interpret that? Well, we say because our p-value of 0.0097 is less than the alpha of 0.05, we reject H0. We have evidence, right? Because it's super low probability we would get our sample if the first one was true. So we reject you. We change our mind. I believe you now, all right? I believe you because I have evidence that I have to change my assumption, all right? So we have convincing evidence that the true mean salary for accounting graduates is greater than 48,722. Same thing here. We reject because our p-value is less than our alpha. We have convincing evidence that the true mean number of credit cards carried by undergraduates is less than 4.09. And notice the wording here. This matches our hypothesis right there. So make sure that matches your alternate. And that's it.